We're looking at place value again. We are looking at what each digit in a number represents, as far as if it's the ones place, the hundreds place, the millions place, the quadrillions place. We're looking at all of that type of stuff. I'm also going to show you how to write it in scientific notation or exponential form. Now when we write it in expanded form, we're going to be using this, so it's going to be important to understand how I get these numbers, so pay close attention. So the first thing I did, as you'll see here, is I made a chart. It is my suggestion to you in your notes to make this chart as well. Now on the top line there, I put digits going across the top to make a number, a rather large number. The number actually reads 3,629,745. It's actually the amount of money in my bank account right now. Not. So now I need to go back to second grade and start identifying some of these place values. Obviously, my 5 is in my ones place. So in this first box under here, I'm going to write the word form of that place value. Ones. My 4 is in my tens place. I'm going through these very quickly because we're in 5th grade, not in 2nd grade. If this was 2nd grade, I would go through them much slower. But I am hoping that at this point we know our ones, tens, hundreds, and thousands at the very least. 7 is obviously in my hundreds place. My 9 is in my thousands place. Putting my 2 in my 10,000s place. Followed by my 100,000. And a really cool number known as millions. All well and good there. Pretty straightforward. Obviously, after the millions place, my next place value to my left would be my 10 millions, followed by my 100 millions, which would then take me to my billions, and then going through that order again of 10, hundreds, and then my new unit star. So we're going to now take these digits, this 5, this 4, this 7, the 9, the 2, the 6, and the 3, and we're going to write them based on their place value in exponential form. The exponential form is taking a number and putting it, raising it to the power of, to a 10 to a power of a number, in order to identify that place value. So looking at the numbers that we have here in this extended number and singling out each digit, I'm going to look at this 4 here that we have represented in our tens place according to our chart. And because I want to hold that place, that digit of 4 in my tens place, I can write it as 4 times 10 to the first power. Now that represents 4 times 10 to the first power represents the same as 40. 4 times 10 to the first power is the same as 40. Now the quick easy way that I remember that is that every one of these exponents, the number that is raised here, accounts for the number of zeros behind the pre-existing number. Now we know that 4 tens represents 40, and that is why I have my exponent raised to the first power. So let's work to fill in the rest of this chart. Now that we have an understanding of where we're getting these exponents and why we are raising them to certain powers, let's continue to fill in our chart. Now we had originally said on our example that 4 that is in the tens place should be 4, I'm going to do it sideways to have more room, times 10 to the first power. You would do it to the first power again because that is how many zeros it is holding that place value for. It's only holding one place value behind where the 4 is living, That's where that one is coming from. Vice versa, we keep going with this. My 7 is going to be raised to the second power because it's 100. And if you think of the hundredths place, it has exactly 2 zeros behind it, so that is why we raise it to the second power, because it is holding those 2 place values behind it in the ones place and the tens place to make sure nobody's able to get into those. Okay, we want it to be in this 7, or in this hundredths place. The 7 only is supposed to live there, so he has to be there, and that is what those exponents are holding for him. Keeping that same pattern going, I'm going to be doing 9 times 10 to the third power, because in the behind the thousands place, I have 1, 2, 3 zeros, 3 place values behind it. My exponent is raised to the third power. My 2 is going to be raised to the fourth power, 2 times 10 to the fourth power. Keeping it going along, 6 is in the hundred thousands place. Now if you think of what the hundred thousands place is, behind the hundred thousands place there are 5 extra digits. So that's what we're going to raise it to. And finally my millionths place is in my 7th place value. I'm sorry, my 6th place value, so I raise it to my 6th power. Now you'll notice, by chance, I did not do the ones place. We kind of skipped over our ones place here. I did that on purpose because the ones place is special. There's no whole numbers behind the ones place. There are decimals and fractions that live behind their parts of it, but in a whole number there's nothing behind it. So if I raise it to a number, I don't know an exponential form how I would do that. I know the tens place I have 1 place value behind this, so that's why I put that 1 there. So the way to get around this is to take whatever you have in your ones place. In our case it's a 5 times 10, and because there's nothing behind there, because it doesn't have to stay in that place for anything but that, nobody really wants to be in the ones place, we raise it to the 0 power because there are no zeros in the ones place. Okay? So no zeros behind the ones place. So writing this out as exponential form takes a lot less space now using that expanded form in exponential form, because we would simply write it as 3 times 10 to the 6 plus, with parentheses because we know our order of operations, plus parentheses 6 times 10 to the 5th plus parentheses 2 times 10 to the 4th plus parentheses 9 times 10 to the 3rd parentheses plus 4 times 10 to the 1st power plus 5 times 10 to the 0 power.